Hello and welcome to Unit 3, Part 4. My name is Mr. Bell, and today we're going to talk about simplifying and applying the exponent rules. This slide says to use exponent rules to simplify the following expressions. Let's take a look at number 1. Number 1 says x to the 4th power times x to the 6th power. Well, the rule to remember here is that when you're multiplying like bases, you can just add the exponents. So in this sense, x to the 4th times x to the 6th gives you a result of x to the 10th power. And think about it for a second. X to the 4th is actually 4 x's, right? X times x times x times x. X to the 6th would be multiplying x by itself 6 times. Well, now if you counted how many total you have, 4 plus 6 gives you a result of 10. Take a look at number 2. 2 says a to the 8th power divided by a to the 3rd power. Well, the rule here is when you divide like bases, you subtract the exponents. So in this case, 8 minus 3 gives you 5. So the result is a to the 5th. Another way to think of this is if there are 8 a's on top, I think that's 8, and then you have 3 a's on the bottom, if you crossed out the stuff that's the same on top and bottom, you're left with 5 a's on top, which gives us our answer of a to the 5th power. And number 3, anything to the 0 power is always 1. You could test that in the calculator if you wanted to. In this case, c to the 0 power, the answer is 1. Take a look at example number 4. It says y to the negative 4th power. Now in algebra, when you're simplifying, you're not supposed to leave negative exponents if possible. Well, here's how you can get rid of a negative exponent. You can move it to the opposite side that it's on. What do I mean by that? Y to the negative 4th right now is sitting on top. Well, if I take that y to the negative 4, move it to the bottom, I can change it to a positive number. But how do I know it's on the bottom? Don't forget there's an understood times 1 in front of any letter or number in algebra, so that 1 is what remains on top. Okay, I know that's tricky. Let's do another example below it just for fun. If you had a to the negative 3rd power, you need to take that a to the negative 3, move it to the bottom to make it a positive 3, and remember that there's a 1 on top. That's how you simplify negative exponents. If the negative began on the bottom, to make it positive, you would need to then move it to the top, in which case this would be your result, a to the 5th power. All right, take a look at number 5. When you have power of a power, that means x to the 4th power, all taken to the 3rd power again. Well, to save yourself some time, you can just multiply those exponents. 4 times 3 gives you a result of 12. And think of it this way. This is like saying x to the 4th times x to the 4th times x to the 4th because of that outside 3rd power. And then you can count them. There's 4 here, 4 here, 4 here, making for a total of 12. And number 6, anything to the 1st power is that base number itself. So for instance, a to the 1st power is just an a. Take a look at these last 2 examples. These are the same rules as the previous 2 slides, except they're all mixed in together and you just kind of have to do them a little bit at a time like a puzzle. So let's start. This number 7, 2x to the 4th, y to the negative 3rd power is all being taken to the negative 2nd power. Where I like to start is to go ahead and do the power of the power. Apply this negative 2nd power to every exponent on the inside by multiplying. We'll begin there. This first one, the 2, has an understood 1 that's not always written. So this becomes 2 to the negative 2nd power when I multiply those exponents. The x becomes 4 times negative 2, which is a negative 8. And the negative 3 times negative 2 gives you a y to the positive 6. So let's keep on working. Remember, one of the previous rules is you can't have a negative exponent. So I need to go ahead and draw a fraction bar, bring the 2 to the 2nd to the bottom to make it positive, bring the x to the 8th to the bottom to convert it to positive. My y to the 6th was already positive, so it would stay on top. And one last step for the simplification, 2 to the 2nd power here gives you a result of 4, and then x to the 8 on bottom. Take a look at number 8. I would go ahead and draw my fraction bar. That's just how I would like to do it. 8 over 4 reduces to 2 on the top, not on the bottom. Your x to the 3rd over x to the 3rd. Remember, you subtract exponents on top and bottom. 3 minus 3 is 0, so they kind of cancel each other out. The y's, I like to go ahead and make them positive first before I apply the subtraction rule. So I'm going to take the y to the -2 from the top, put it on bottom, make it positive. The y to the -4 from the bottom, move it to the top to make it positive. And the z to the 6 over z to the 1, remember you subtract those exponents. And another way to think about it, you subtract them and you put the leftovers where the most were to begin with. Meaning I had 6 of them on top and only 1 of them on bottom. That's a difference of 5. Well, if I take 1 away from each one, I had more on top to begin with. So that's where my 5 remaining z's will be. Let's apply that one last rule with my like bases here, the y's. You have y to the 4th on top over y to the 2nd. So bring everything else down. And the y values, 4 minus 2 gives you y to the 2. And also remember, if you crossed out 2 of the y's from here and 2 of the y's from here, the 2 that are left over are still on the top. All right. Thank you for watching and hope this helps.